All right, in this video, we will simplify irrational expressions, and I will use factoring to simplify the rational expressions. So we're back to your favorite thing, which is to factor. Yay, smiley face. All right, let's take a look. I'm going to go through about 5 examples for you and then let you try a couple on your own. All right, what we're going to do is we're going to simplify, and then we're going to do another thing here, which is to identify any x values for which the expression is undefined. And if you'll recall that an expression will be undefined when the denominator equals 0. All right, so let's take a look at our first expression here of 8 over 4x minus 12. And in our numerator, we have an 8, so really there's nothing we can do there. The denominator, we have a 4x minus 12. Now, before we get started, let me remind you and caution you that 4x minus 12, they are attached, right? So if you are going to want to try to simplify or to reduce them down before you simplify, put the parentheses around them so you will not do that. Okay, so let's come over. Like I said, there's nothing I can do in the numerator. In the denominator, however, I have a 4x minus 12. I do see that both of those contain a greatest common factor of 4, which I will factor out. So let's do that. So I'll have 8 in the numerator, and then in the denominator, I'll factor out that 4, leaving me with an x minus a 3 left inside the parentheses. Now at this point, since I have factored out that greatest common factor of 4, it is being multiplied by the x minus 3, and now I can simplify it if that is possible. And in this case, it is possible. An 8 and a 4 will reduce down to a 2 and a 1, giving me a simplified final version of 2 over x minus 3. So we've simplified it down, and now we have to figure out where this denominator will equal 0 to see where it will be undefined. So if I have an x minus 3 equal to 0, I know that that will be undefined when x equals a positive 3. All right. Let's take a look at this one. We have a 3x minus 12 over an x squared minus 4x. Notice that they are attached with subtraction. So if you think you're going to try to simplify these down before you factor, put parentheses around them. So let's look at the numerator. I've got a 3 and a 12. So could we factor a greatest common factor of 3? I think we can. And in the denominator, we have an x squared minus 4x. They both contain the x, so that means I can take out the smallest exponent, which is power of 1. So let's factor those. So let's factor the 3 out in the numerator, giving us x minus 4. And factoring out the denominator, giving me an x minus 4. Looky there. So here we have a 3 times x minus 4 over x times x minus 4. And now I have a set of factors, that being the x minus 4, that can be canceled out because they are being multiplied up here by the 3 and down here by the x. And those will cancel and go to 1, leaving me with 3 over the x for my simplified version. And now I need to figure out where this denominator is going to equal 0. Well, if this will equal 0 when x equals 0. Now, since we had a degree of 2 in the denominator, that does mean we will have 2 situations where this will be undefined. So we must go back to where we originally factored, and we see that we have that x times that x minus 4. So we have to find where that x minus 4 could possibly equal 0, because if we multiplied those together, we would get that 0 in the denominator. And in this case, x minus 4 would go to 0 when x equals a positive 4. So 2 situations where we will have this expression being undefined. Again, undefined when the denominator equals 0. Moving on to our next one, we have an x plus 5 over an x squared minus 25. Numerator, I'm going going to put parentheses around it, and I'm going to put parentheses around the denominator because I know they are attached with a plus and minus. I cannot simplify them down. Now look at your denominator. I hope you're looking at the fact that you do have a power of 2, so we are going to be doing some factoring. I don't see a greatest common factor, but I do see a pattern. I see my x squared, I see 2 terms that are being subtracted, and I also know that 25 is a perfect square. You figuring this out? Is this our difference of 2 squares, right? Which factors into a plus b and a minus b. So in this case, our a is the x, and our b, what's the square root of 25? Okay, so let's factor the denominator. So I end up with an x plus 5 over an x plus 5 times an x minus 5. And my x plus 5s, they match up perfectly, so we can reduce those, leaving me with a 1 over the x minus 5. Now, when will this be undefined? So let's take a look at our final here, that x minus 5. That would be undefined when x equals positive 5. Since we had a power of 2, go back to where we first factored, and the x plus 5. X plus 5 would equal 0 when x is minus 5. Okay. Now let's see what we have. An x squared plus an x minus a 2 over an x squared plus a 2x minus a 3. Well, we have quadratics in numerator and denominator. That is in our form of ax squared plus bx plus c. So we're going to use our x method. Let's take the numerator first. We have a negative 2 for our c and a 1 for our b. So that would give us, what, a 2 and negative 1? And then let's look at the denominator. We have an x squared plus 2x minus 3. So we would have a negative 3 for our c and a 2 for our b. That would be 3 and negative 1. Okay. So let's bring those back in and factor. So for our numerator, we have the x plus 2 times the x minus 1. And the denominator is the x minus 1 times the x plus 3. Now we've got this back into multiplication where we can cancel or reduce if possible. And in this case, the x minus 1s will reduce, become 1, leaving us with the x plus 2 over x plus 3. Now, when will it be undefined? All right, our x plus 3, that will go to 0 when x equals negative 3. And let's go back over to when we first factored them to the x minus 1. And that will go to 0 when x equals a positive 1. All right, I'm going to do one more here with you. And in this case, our numerator is simplified down. We can't do anything with it. It has a degree of 1, and they're attached. So we can't do anything with that. However, the denominator is in our ax squared plus bx plus c form. So we'll go back to our x method. This one has the 3 or the a value, so we will have to bring that into our x method. So we start off with taking the 3 times the negative 4, which would give us a negative 12 over our b of 1. So that would give us a positive 4 and negative 3. Don't forget that 3 needs to be divided out. And we see over here that that will simplify down to a negative 1. And don't forget, when we have a fraction over here for factors, it is the denominator, in this case the 3, that will become, will become the x coefficient. So let's bring those back over. So our 3x plus 4 in the numerator, now our 2 factors here, the 3x plus 4 down here. Noticing that Our 3 is the coefficient, and our x minus 1. So we have a 3x plus 4 that cancels, so those will go to 1, leaving us with a 1 over x minus 1. Last time again, let's figure out where this will be undefined. My x minus 1, that will go to 0 when x equals a positive 1. And my 3x plus 4, that will go to 0 when x equals a negative 4 divided by 3. And your last slide here gives you some problems to work on. I have already done some for you. Notice I have done question 1, question 5, and question 6. And I will post for you any of the other ones that I want you to do on this one. All right, and you'll bring this plus your notes back